now we're going to take a look at what happens at x-intercepts. So there are two things that can happen when I find an x-intercept. Let me just give you a little visual here. Let's just say I have a 2 here and I have a -3 here. I can have a graph go through an x-intercept. I could also have the graph, I could have a graph bounce off. That's supposed to be a smooth curve. Bounce off. All right, an x-intercept. So we have a going through and we have a bouncing off. And you can see why that would be a helpful thing to know about a polynomial, whether it bounces or goes through a particular x-intercept. So the directions say find the x-intercepts and determine whether the graph of the function crosses the x-axis at each x-intercept. Determine whether it crosses. If it doesn't cross, then it's obviously going to bounce. Okay, so let's take a look at this. They first want us to find the x-intercepts. So to find x-intercepts, I obviously make the y a 0. Okay, so that's my first step. Make the y 0. That's how I get an x-intercept, where it means the height of the point is 0 there. So now I have these factors set equal to 0, so I'm going to go ahead and set each of them equal to 0, right? Now this means x plus 1 times x plus 1 equal to 0, and this is obviously just this. And so this one over here is a 4, and these here, when I set them equal to 0, I'm going to go ahead and do it this way. When I set each of them equal to 0, I get x is -1 and x is -1. So I have 3 x-intercepts here. I'm going to move this out of the way so I can list them. I have x is -1, but it actually shows up twice, so I call that multiplicity 2. I have another x-intercept at 4, and I don't call that really multiplicity 1, but it just occurs one time. Okay, so here's what we know. When I have an actual multiplicity that's even, meaning 2, 4, 6, 8, okay, then that means it bounces off that x-intercept. It really does touch it, so it really is an x-intercept. It does intersect or intercept the x-axis, but it bounces instead of going through. Okay? So that, in contrast, if I have an x-intercept that has an odd power, okay? In other words, look at this over here. It had a 1 to the first power, which means it occurred one time. If it occurs one time or 3 times or 5 times, right, then that means that it's going to go through the x-axis at that point, at that x-intercept. Okay? So an even number of times means it bounces. An odd number of times that it's present means it goes through. Alright, so there's the blue one. Let's go on to the next one here. It says to find the x-intercept first. So again, I'm going to make the y 0. Now this is not quadratic, so I can't just factor it, you know, like reverse FOIL or whatever, but I do notice that I can factor it. So I'm going to go ahead and pull out the common x. That's always the first thing to ask. Can I pull out a common factor, a greatest common factor? And when I pull out the greatest common factor, it just so happens that the other factor is factorable as well. Right? There's an x. And that's going to be what? Plus 4 and minus 1. I think that's what that'll factor into. So now I'm going to set each of these equal to 0. This is just me getting the x-intercepts. Okay, so now this is an x-intercept. Here's an x-intercept of 1. It looks like that each of these occur one time, right? This is to the first power, the first power, the first power. They show up one time each. So we know then that at x equals 0, the graph is going to go through the x-axis. At x is -4, it's going to go through the x-axis. And at x is 1, it's going to go through the x-axis. Okie doke? Pretty simple, right? Alright, so let's just have a couple of seconds here. Let's just take a look at what a sketch might be like. If I were just going to sketch kind of like the end behavior and maybe just the x-intercept situation. There's 0, I have 1, and I have a -4. Okay, there's my 0, there's 1 and -4. So this is to the third power. It's a cubic. And I know that cubic functions do this. They make this kind of shape, right? We know that we've had experience with cubic, so this is what's going to happen. This has to end up doing this on the ends, and then I don't know how much it's going to pass through, but I'm just going to give a basic sketch. It has to pass through at -4, it has to pass through at 0, and it also has to pass through at 1, and it has to end up going to infinity. As x goes greater, the y value goes to infinity in the positive direction. So that does actually make sense, right? That it would go through and that it would actually be a cubic. Okie doke? Hope that helped. Thanks for watching.